Hello everyone. So we'll start with the next chapter in your module 2. This is the third chapter in module 2, and according to your syllabus in your textbook pattern, it is the chapter number 4. So this chapter speaks about the SQL and its different constructs, how exactly to create a database physically, because in the previous chapters we have learned relational algebra. Before that we have learned how to map a ER diagram to a relational diagram. So after that we have learned some relational algebra construct with respect to the operations on it, set operations. Now we will go with this SQL as a part of it in order to perform the operations on the given set of data. So anyhow, by now you all familiar with what exactly a database, what is a ER diagram, the requirement analysis, followed by the mapping process, then mapping it to a relational model. Now once I say about the relational model, we need to understand that there should be some language in order to communicate with this relational model. See, one of the grand success of the relational data model was with the help of a use of SQL programming language. So what is this SQL as it's been written on the board? It's a structured query language, which is also called as Sql, that is structured English query language. Actually, this was designed as an interface for one of the IBM System R machine. Later on, gradually it increased, like the growth happened in such a way that the hierarchical model and the network model, then came the relational model, as you already know. So in this relational model, to make it a grand success, they use SQL programming in order to perform the accessing of data from the database. So when I speak about the SQL programming languages, it has different constructs in it. Such as we have data definition language, which is called as DDL. We have data manipulation language, which is called as DML. Okay, anyhow, it will all be covered in next coming classes. So I'll just read down DDL and DML. So these are the two main constructs, and it's there are a number of different commands in it in order to create, manipulate the data in the database. So before speaking about the database as a terminology, we call it as a relational in general with respect to a relational model. There are some terminologies you need to cope up with. Say for example, you might call as an instance, or you might call as an attribute. In relational we call it as a column, and the instance is called as a row. Okay, whatever you call as relational model, here we call it as a table. So there are some terminologies which I will be interchangeably using with respect to your relational model and the way it has to be used in the SQL programming language. Anyhow, you will be well versed with as and when the classes will be commenced with one another topic. In today's session, I will be going with this first particular topic under this chapter, that is SQL data definition and data types. Under that we have these two subtopics initially, that is schema and catalog concepts in SQL, and the next one is the create command. Okay, so let me first explain what is this schema and catalog concepts in SQL. See, as you can understand that a schema is nothing but a database. Okay, a relational model, whatever you want to think of. Say for example, schema is one which gives us how many tables we have, what are the constructs we have, what are the constraints we put on those tables, what are the views we are creating on those tables. So all together they are called as schemas. So normally if we go to your laboratory terminologies, we call it as a database. Okay, we call the schema as a database because schema gives us a correct insight what exactly or what type of data, where exactly I am storing my data in order to process it. So all this kind of information will be stored in this schema. So creating a schema is the first process you are supposed to do before learning any SQL programming context. So because you require, it's like a repository where you store all your data and where you manipulate it. After manipulation, again the modified data should be stored back there, right? So all this happens with the help of a schema. In turn means that a database. So the first process you are supposed to do is you need to understand what is schema. See, do not get confused with a schema diagram what we write. Actually we write schema diagram this way. We use this the name of a entity as a name of a relation. Say for example, if I take a student as a relation name, and we have the attributes of student, USN, a name, okay, age, marks, and so informations. So this way this can be called as a schema diagram, because it gives us a picture of what exactly I'll be storing in the backend database. Say I have a student data, student has information like a USN, a name, a age, and a marks, and so okay. And it says that if I say USN is a unique value, it says that it should be a primary key, or it has to take the unique value. So all this kind of information I can go with, like, so again if I say I have a faculty table, and all the attributes of faculty will come next. So it's all belong to a college database. Now the college is called as what? A schema. Hope you followed it. See, these are all the actual tables what I am going to create in this schema called as a college. Because as a schema, it says that when I say a college as a schema, we can understand that college has students, it has faculties, it has departments, okay, it has administration section, it has placement. So all this real world entities come in the form of tables based on the requirement of the end user. So hope you people had an insight of what exactly I am speaking about this word called as schema. Fine. So as you can see, there is one more way of creating a database, as I spoke about just now. Create schema, or else instead of a schema keyword, you can also use in MySQL create database and a name for it. Okay, so they are creating a create schema company, okay, followed by authorization is been given. What is this authorization? In the sense, the person who owns this schema or the database. So authorization keyword has been used while creating it, followed by a name of a person, okay, who can access it through the login ID and password should be entered during the creation of this schema itself. So create schema company, authorization is a keyword, and this is the name of a schema or a name of a database. Just now I took an example of a college, the same way I have an example of a company here. And Arun. So Arun, I have called him a name who is authorized to perform operations on this company, or perform modification, changes, add and deletion, all the operations can be performed by this person. So this is a general example of what exactly a schema is. Now this schema, whenever you initially define it, we require a create table command, okay, a create command, sorry, not a create table, a create command. So the create command, what you can see initially is what lets us to create the schema for us, okay. While using this create, I'll specify a name of a schema, followed by this I need to create some more tables inside it. For that I required the create table command. So the create is a command used to create a schema as well as the tables inside it. So that is the reason we need to learn the create command next. So before going to the create command, there is one more terminology used here called as catalog. So hopefully in the first module itself you might have been thought about this catalog. So catalog is nothing but it's a description of a database. It holds the description. Say for example, if you are trying to query something to a database, and you write a small query, say I want to fetch so and so data. So I need not search in the whole database for what I am requesting, only go through this catalog. It's a metadata, as you all know, it's a description of the whole database. Say for example, my query is on a student database. Okay, I am trying to view the marks of a particular student. So, and if I am trying to search in the company database, will I able to get it? No, if I search the whole database also, there is no match for that particular request what I am giving. So what does catalog will do here is, as soon as you give a request, it will be it will look like something like this. If you, this is your database, inside database I will be having a catalog in a small position. Okay. So whenever the request is given, this catalog consists of description. What description? What and all table we have in this database. Say for example, if I say company, I have employee table, I have a project table, department table, so and so tables has been stored. If I am giving a query on a student based on some marks, I will search for a student table. Do I find it student table in this catalog? No. Then no need of going to search the whole database itself. That is what this catalog is. Now what this catalog is doing with schema is, whenever you define your schema, then and there, by using the create command, you will be defining the definition of all the tables with the help of this create command to make a benefit out of catalog. Okay, we will see that how to define the definitions of each relation by using this create command for the catalog. So in general, just understand that a catalog is one which stores the description of the whole database. Say description in the sense how many tables I have, how many attributes do each table have, what are the constraints which I am putting on those tables, what are the domains of attributes. Okay, all this called as what? The constructs which come under this catalog. Okay, so hope I made you clear with what exactly a schema and a catalog is. Okay, now we will go with the create command in order to create the tables. So the syntax wherein which you use the keyword is the create followed by a table and the followed by a name has to be used for it. See, I will go with some more examples of create command as and when the class commences. So now the basic thing with respect to creating a tables inside a schema is, the first thing is you need to specify under which schema you want to create these tables. Right now, if I want to create this schema under a college schema, so I need to specify create table college.student. One way you can do that, or else you can just after creating the previous command, that is create schema college or create schema company authorization Arun. After that command, if you run this, automatically it is understood that you are running. Or else you can tell in your lab, if you are using MySQL, you can use this command, use database name. If you use this, database name might be a college or a company, in whatever the case if you are using, you can specify in that way. After you use this command, you can go with directly with this one. Okay, so create table student followed by the attributes. Okay, attributes have name, attributes have domains. So this attributes and domains will come in the next part, because there are different types of data types as a part of a domain you need to learn. In this particular topic, as part of this one, just understand how to create a table or a relation in your relational terminologies. So create table student. So table should be a keyword being used followed by a table name followed by its attributes. Okay, so this is the way you supposed to create a relation. Like this, you can create n number of relations. But when I say a relation or a table, as I mentioned, I'll be using interchangeably. There are some constants, or I can call it as a constraints, you need to be following throughout the course of creation. See, when I say a relational database, it's a name only saying that there should be relation between the tables in order to have a proper interpretation of a data what is present there. So I have a student, I have a faculty, if I have a department, means what is the use of it? We need to have an interrelation. Say students been assigned to departments, faculty teach to students, faculties work for department, college as department. So this way we need to have a ER diagram being written for that. So same way we need to have a relation. For that we need to have a constraints. So whatever the constraints you have learned in the part of the previous chapter, might be key constraint, might be entity integrity constraint, referential integrity constraint, domain constraint. So all these constraints should be provided through this create command itself. Okay, so all this we'll learn next. Before that, I'll just go through with some of the basics data types which are required in order to create a simple table. Okay, let us see that now. As I said, the first set of types or the domains what we can give for attributes. This is not the thing, we have some more. I'll come next. So the first set is the numeric. So numeric in the sense we have integer, floating point, real, and as well as decimal for the case of formatted output. See, first of all, let me tell you, anyhow you are all familiar with different programming languages. There you might be used the word called as data types. It speaks about the domain, like what type of values I can fill for a particular attribute. Say for example, I'll say age as an attribute for student. So I'll give int. What it says, while filling the values for age for a student, do enter an integer number. So this way it is. So the purpose for specifying the attributes and its domain during the creation by using a create table command is in order to restrict the user to enter the values within the domain. Okay. So the first set of attributes, hope you got an idea now what exactly a data types is. The first set of is the numeric one. So we have int for integer numbers as example of age, float if you have decimal values, and the real if the number is used like a phone number, something like that, you can go for the real, and the decimal of I comma j, it is about the formatting the output. Say the I indicates the number of the digits, the precision, okay, and j indicates the decimal values after the decimal point. Okay, so I comma j. Say for example, if I say 2 comma 4, something like this, so this indicates 1 2 dot 0 1 0 1, something like this. So this indicates what is the formatted way of specifying the numeric type in case of the requirement arises. Okay. So int, float, real, and decimal. Anyhow, no much explanation required I feel for integers, as I spoke, float and real and decimal. The next type is the character string. So there are two variants inside it. We have a char of n and var char of n. So now what is this char indicates us to take a set of characters as an input. Say for example name. So I can go with name for character of some 11 digits. So I can enter a name within 10 characters of a name. So I can use character of name at that time. Say for example name as character of 10. Okay, while creating a table. So this indicates this name for a student table can take 10 bytes of character, 10 in the case 9. So it should be 11 for 10 because it's always one less than that. Last will be the terminating. So why do we require this var char? Also stands for variable character. Okay. See, sometimes there are two main differences. I'll come to that next. The first thing is if you have a string to be taken, which is a combinations of both characters and some numbers in it, then we need to go for this type of data type called as variable character. Say for example your USN in the VTU standard, where we have something like 4 MHIS followed by so and so stuff. So there is numbers as well as there are characters. So in this scenarios you need to go with the data type called as a varchar, where you have a combinations of character as well as the numbers. So as I said, if I have a USN, I'll go with varchar of some 11 because your USNs of 10 bytes. Okay, so this way you can have a variable character being used for specifying combinations of characters and numbers. Now, apart from this one difference, that is, it can only take characters, it can take both characters and numbers. The one more difference is the way it is being accessed with respect to the memory allocation. let me tell you people, say for example, I'll take name of varchar, let me take 10 and 10. Okay, I've taken name of character of 10, I have taken name of varchar of 10. Assume that I'll fill a name called as Arun. Okay, now what happens here is, irrespective of whatever the size you have taken, okay, in case of name of varchar or name of character, I have filled name value Arun for this attribute name. So automatically the remaining will be filled with the blank characters to make it of size 10, that is 9 bytes, 0 to 9. Okay, which is happening in which case? In this case, character of 10. But when I come to the variable character case, what happens is, when I give Arun, if it is allocating 9 bytes of data, that is 10 in the case of size, but it will not be padded with any blank characters. It will be truncated to the whatever the value you are inserting to this variable name, irrespective of whatever the size you have given, doesn't matter here. In case of what? Variable character. Okay, so that is the second difference between the character and the varchar. Okay, I'll just brief out once. In case of character, can only take the characters, that is the alphabets, whereas in varchar it can take both alphabets and numbers. First difference. Second difference is, if I say character of 10 for a name and if I take varchar of 10 for another name, so it will be of 10 itself by padding blank character, blank bytes. Okay, in case of this, it will be truncated to the size whatever. So 4 means only 4 has been taken, remaining can be used with some other variables or some other attributes. So this is the difference between character and varchar, which come under character string. So again we will see this examples in when we use with create command. Okay, the next set of data types is the bit string, what you can see there. So it is used to represent the binary values if it is required in the case of storing images. In the case of in the backend database, we will be using this. So we have a bit or bit variable, as we have char and char variable here also. So I have taken only one here. So bit of n. So n specifies as the maximum number of bits. By default it takes 1 bit, that is 1. So in order to represent the values, we use b as a starting up flag followed by the number of bits. So the way the value will be given for this. So if you have some attributes which are of type binary values, I'll be using this bit string data type for that. Okay, bit or bit varying is also possible if you have a variable length. In the case as I spoke about, same concepts apply here. That is, you can have binary numbers of some predefined size and padded with some blank characters, or you can have a specific size value with a bit varying. Okay. There's two more thing called as blob and clob, that is binary large image. Whenever you want to store a image in the backend database, I say for example, you might have seen in some applications they will ask you to upload your image as a document. Okay, so in that case, a image as an attribute will take a type of a blob, binary large image. So blob and clob will be used for those kind of values in the stored data in the form of megabytes or gigabytes. So for that reason, we'll be using blob and clob. So this will be covered in detail in the next coming chapters, where we end up in understanding that a blob where it will be used effectively only when we have the binarization of an image, because when we store an image, it is what the pixel values, the ones and zeros, the combinations of it will be stored in the backend. So that is the blob is what the one used for it. Okay. Then comes your Boolean type. As all you people might aware of this, two values we have, that is true as well as false. But in SQL we have one more type called as unknown with the Boolean value. Why this unknown comes into picture here is, you might have heard of null values, and while filling a data to a database we might encounter null. Null in the sense the value might be missing. There are several ways we can interpret a null. You might know the value, person might not insert the value. Say for example age age is given null. What it indicates? Age should be there for a person, but it is missing there. Or else, for example, phone number, it might be missing. I have put null there. What does null indicates? There might be a phone number or it not be a phone number, but it is missing at that case. Age, it is there but missing. Phone number, I don't know whether it is present, but also it is missing. So this kind, you can have n number of interpretations. That is also will be covered in the next coming classes. But unknown is also a Boolean type in case of your SQL. Okay. The next set of data types is date, is what the first we have. So in SQL we have a data type called as date in order to store the date of a given attribute. Say for example, for an employee, date of joining, we can have a date as a data type, or date of birth for a student, we can have date as a data type. So there the format of date what we need to use is years, month and day. Means whenever we have an attribute given of this data type called as date, the values what I am supposed to insert should be of this format itself. That is, we need to have 1998, okay, followed by the month 09, then followed by the day. Okay, so this way only the values has to be inserted. So date is a data type in SQL which takes the values in the format of year, month and day. Same way we have a data type for time also. So we can also insert time. Say for example, at what time you have registered for a particular application, if an application like that, or if you go to your online shopping applications where you book some products, at what date and at what time you are booked. So all data has to be stored in the backend. No, so for those type of data we need to have an attribute, should have a type called as time. Okay, and the format of time should be hours, minutes and seconds. Okay, say for example 10 hours, okay, 12 minutes followed by some 58 seconds, something like this can be given. Okay, so hours, minutes and second is the format you are supposed to give for time data type for a table, for an attribute of a table. Okay, as I give an example of shopping, or you can go with an example of an employee and a project. So there might be a relation of employee works on a project, at what time he started working on a project and at what time he finished working on a project on the same day. So the time can be used as an attribute there. Login time and logout time is a time type. Okay, login as an attribute is a data type of what? Time. And there's one more called as a timestamp, which is normally used for specifying the time zone based with respect to the value of time and date together, the combination. So it's a combinations of, as you can see, the date and the hours, that is the time, followed by decimal point of 6 digits, which indicates the seconds, the millisecond values for the given time zone. Okay, an example of that is, say for example 2008, 9 and 77 is the date, followed by the time, followed by the decimal point, followed by the 6-digit decimal number, which indicates the seconds for the time zone being taken place. Time zone in the sense, as you all know, the time zone of, say for example, we have the Kolkata time zone being followed, or the Americans follow different time zones. So based on the time zone, the seconds and the milliseconds will be present in that 6 digits precision value. Okay, this is the timestamp. So normally this will be occasionally used, wherein which if you are designing an application for the global purpose, at that time you will be using timestamp. But normally for the real world applications, what we can see in and around in our life, we will be using the date as well as time. So the few data types what we have seen today is the first one was your int, that is a numeric, int, float, real, or the formatted numeric part by using I comma j value. And after that we have just seen character, that is difference between character and varchar, and followed by that we have seen the bit string, okay, the Boolean values, followed by the date, time and timestamp. So these are some of the domain or the data types which are being used for the specifying data types for attributes. Okay, so in the next coming online session, to summarize in today's online session, we just go start with the introduction part of your SQL, what is schema, what is catalog, and what is create command being used, and what are the different data types being used to specify the attributes of a create command. So next we'll go with the examples of create command with the help of these data types in the next coming class. Okay, thank you all.